This video covers the basics of dimensioning in AutoCAD. Before I start dimensioning, I want to make sure I'm on the correct layer. So I'm going to change the layer to dimensions. And just for the purposes of this video, red is a little hard to see on the black screen. I'm going to change the color of the dimensions layer to something a little bit more visible. You do not need to do this for your homework. Dimensions are on the Annotate tab. And at their most basic level, we simply pick what type of dimension we want to apply. For example, a linear dimension. And then we usually take advantage of object snaps to precisely place that dimension. And before we do our final click, we move the dimension where we want it. Last click, and we have a dimension. A few things before we start applying dimensions. You may look at this and notice that the dimension seems a little big for the part we have. And that will certainly be true. If we were drawing a larger part, this dimension would be too small. So one of the first things you want to do when you're dimensioning is set up your dimension styles. In AutoCAD, dimension styles are accessed right here. You get a dialog box. While you can certainly create your own dimension styles, we'll just work with the standard dimension style and we will modify it. A few useful things to note inside the modifying the dimension style is the text tab and the text height. This would allow us to make this text a little bit smaller and fit the drawing a little bit better. But it wouldn't do anything for the rest of the dimensions, say the arrowheads and the leaders. A better option in this case is fit. Over here we have an option to use an overall scale. Let's change the overall scale in this drawing to 0.75. OK, close, and now our dimension is sized much more appropriately. Now that we have that set, there are two strategies for linear dimensions. One is called baseline. So I'm going to start here and put in my dimension to the first hole. Then I'm going to come up to the and choose baseline. Now, as I continue to click features, AutoCAD puts in dimensions, essentially using this surface as a datum. All features are dimensioned from this datum. If I were to do the same thing in the vertical direction, I would add my first dimension, click baseline, add my second dimension. Sometimes when you're using baseline, the dimensions are a little bit too close. So here we have an extension line touching my other dimension. That's not the end of the world, but not especially good practice. So dimensions come with grips. If I click the dimension, I can click on this grip and I can just move that dimension over a little bit. It's also considered poor practice to have your dimension lines, your extension lines, these are extension lines, crossing your part geometry. You want to minimize that wherever you can. So again, we can use grips to do that. I'm going to simply grab this dimension, I'm going to grab this grip, and I'm going to drag it back down to be on this line. Note that I'm using my object snap. I'm finding the intersection of the current extension line and my object line so that my dimension stays what it is. You want to be very, very careful when you're doing this that you don't accidentally, say, do something like this in the extreme, shorten something and you get the wrong dimension. This is where you certainly, if you're in a very complex drawing, you might want to change which object snaps you have turned on, or you might want to just go ahead and override your object snaps. All right, so there we go. There we have a baseline dimensioned part. The other strategy is continuous dimensioning. So I'm going to erase what I've just done. And now I'm going to, as before, place my first dimension. But instead of selecting baseline, I'm going to select continue. Now, as before, I can continue clicking features, but notice that AutoCAD does not dimension everything from a common datum or a common baseline. It simply chains the dimensions together. If we were to do this in the vertical, click continue, and there we have this version. There are some subtle differences in what these two mean, but we'll discuss that in the next lab. For now, we just want to concentrate on how to apply dimensions to drawings. As before, we need to move this extension line back. So one thing with continuous dimensions, if I do this as before, I look at this and I go, well, it doesn't look like I did anything. Well, I did. The issue is that these two dimensions, they both have an extension line, essentially one sitting on top of the other. I shortened the extension line associated with this dimension. I have not shortened the extension line associated with this dimension yet. One way you can get around that is you can drag a window to the right. Notice that selects both dimensions simultaneously. And now when I grab this grip and move it, I move both of them at the same time. I'll do the same thing in the vertical direction. And we have all of our continuous or continue strategy dimensions done for this part, linear dimensions done for this part. Of course, linear dimensions are not the only thing we have to worry about. We have to dimension these diameters. So we will select a diameter dimension. Normally when we're dimensioning circles, holes especially, we dimension by diameter, not radius. When we're dimensioning arcs and those sorts of things, that's where we dimension with a radius. So here we have created a dimension for this circle. This is the diameter symbol. When you're doing a diameter dimension, AutoCAD automatically puts that in for you. Now we certainly could dimension both of these like so, but that would really be considered poor practice. It really clutters up the drawing. We've got an extra dimension line crossing our part boundary. We can't avoid it over here, but we don't want to cause any more of those than we have to. So what we're going to do is we're going to modify this dimension text to show that this dimension applies to two features. So simply double click, and now you've got a cursor. Make sure your cursor's in front, and I'm going to type 2x, and I'm going to press just click off the dimension, and now I have edited this dimension to indicate that both circles have a diameter of 0.50. This is multi-line text, so if you were to do this again, we could say, for example, put a return here, and then say drill and read. And I can, all of your text editing things that you would expect are right up here. We've got justification. We can do that to, let's see, maybe oops. Let's do a middle right. whatever you like to have there. Maybe it would look better in this case if we did middle left. There we go. So, and that doesn't just apply to diameter dimensions. You could also edit any of these linear dimensions. If you don't like the placement of your diameter dimension, simply click on it and use the grip to move it around. We of course could move it back here. This would be considered very, very poor practice, having the extension line of a diameter dimension crossing the dimension line of a linear dimension. So let's go ahead and leave it up here where we had it. A little bit more about editing this text. Suppose instead of drill and ream, we say we want to tap. This is a thread creation operation. Tap 1/2 by 13 UNC threads. So we can do that. There's also, in your text editing, there's a stack button. That'll allow you to create fractions. Click off of there, so now we've got a different thing there. If you need it, there are also symbols. So if you need any of these special symbols, they're available right here. Note that AutoCAD automatically put a center mark in with our diameter dimension. That's something you excuse me, that can be changed with AutoCAD. But we have it set this way in the template, so it's fine to go ahead and leave it. But it does look a little funny that this circle has a center mark and this circle doesn't have a center mark. So to get just a center mark, that option is right here, center mark. Click center mark, click what you want to apply it to, and we've got our extra center mark. Okay, the next thing we want to talk about is how to change the precision of dimensions and how to add tolerances. So when you're drawing, every dimension on a drawing must have a tolerance. It absolutely must. So for example, let's take this dimension here. Let's get rid of this extra text. We'll just make these plain old through holes again. There's two ways to specify a tolerance. One is it is really good practice to have a unspecified tolerances block. So I'm going to go ahead and put in some text here. Say unspecified tolerances. And I don't like how the size of that text, but that's okay. I can change that. That looks a little bit more reasonable. And an unspecified tolerance table looks something like this. If you have 1 decimal place of accuracy, then you put in a tolerance, usually as what we call a symmetric or bilateral tolerance, plus or minus 0.1. Oops. Say 0.1. And then if you have 2 decimal places of precision in your dimension, we use a plus or minus 0.01. And if we have 3 decimal places, let's say 0.003. They don't all have to be 1, right? You can put whatever you want in there. We could say then also angles, put them at plus or minus 0.5 degrees. And put a couple more spaces in there to make it look better. And there, we have an unspecified tolerances block. So note that we had our original dimension styles was set up to give us 2 decimal places of precision. We can certainly change that. So to change it globally for all dimensions, we go to Dimension Styles, and we say Modify, and then we go to Primary Units, and we can change the precision right here. So for example, if I change this to 3 decimal places of precision, say OK, close, notice that all my dimensions have updated to have 3 decimal places of precision. Let's go ahead and change that back, modify, change the primary units back to 2 decimal places. I was pretty happy with that. Close, and they all change. Now, of course, not every dimension on a drawing has the same tolerance. So there might be a particularly critical dimension. So let's say this hole. I'm not happy with plus or minus 10 thousandths here. I want this to be plus or minus 3 thousandths. So to change the precision of an individual dimension, there are really 2 ways to do it. One way is to create an override. This is really useful if you're going to create several dimensions with a different precision. So for example, let's get rid of this. Let's do an override, and let's override the primary units to 3 decimal places. Okay, close. Now when I go place my diameter dimension, it will come in as 3 decimal places. And if I were to go place another dimension, we'll just place a diameter dimension here to show the concept. All future dimensions, notice that dimension is going to come in as 3 decimal places. If I were to put in a linear dimension, not that I would, my drawing is already completely dimensioned, it comes in as having 3 decimal places. We can do the same thing if we don't like this, if we don't like our choices here. So by changing precision, I can change it between plus or minus 10 thousandths, plus or minus 3 thousandths. But what if I wanted plus or minus 1/1000th of an inch? Well, then I need to explicitly specify the tolerance. So we'll get rid of this dimension, go back to our dimension styles, modify, and we'll go to the tolerances tab. And we'll add a symmetric tolerance. And we'll make its upper value, say, 0.001. Now this is really important. It is a rule that the precision of the primary units and the precision of the tolerance must be the same. So here I have 3 decimal places in my override for the primary unit, and I have 3 decimal places in my tolerance. We'll say OK, close this, and now when we bring in a diameter dimension, notice that it's showing up with 3 decimal places of precision, a plus or minus symmetrical tolerance of 0.001, and the precision here is the same as the precision here. When, again, notice that any future dimensions that you bring in with that override are going to have the same properties. To get it to stop or to go back, simply go to your style overrides, right-click, and say delete. Yes, I want to delete my overrides. And now if I go add a dimension, notice that we're back to our standard dimension style. So that's one way to do it, is to set an override and then create your dimension with that override style. That's useful if you're going to do several dimensions. There's another way to do it, so let me show you that way. I'm going to go ahead and add a dimension in our default style. If I click on the dimension and then I right click on the dimension and I select properties, I get a properties box. This properties box can be resized as you like. And this really gives you a lot of power, gives you access to pretty much everything there is to know about that dimension. The useful things are really here. Here we can change the primary units, so we can change the precision of the primary units to 3 decimal places. And we can change the tolerance. We change its display to symmetrical. Put in an upper tolerance limit, 0.001. But notice, in this method, we didn't automatically switch our tolerance precision. We've got 3 decimal places of precision in the basic dimension. We don't have 3 decimal places in the tolerance. So we're going to use this method, we have to change the tolerance precision to 3 decimal places. And when you're done, you can just close that box. So both of those are correct methods for modifying the style of a dimension or a series of dimension. It ultimately comes down to whatever you're comfortable with. If I were making this drawing for a machine shop, and I want fairly rough, I'm happy with plus or minus 10 thousandths on most of my dimensions, I'm probably going to start my drawing with my dimension precision set to 2 decimal places. And that way most of my dimensions I don't have to mess with. Not only is it a little bit easier, but it really cleans up the drawing. If you can imagine all of these dimensions having a plus or minus tolerance on them, you can see things getting pretty crowded pretty quickly. So an unspecified tolerances block, doing it this way, is certainly a good practice. And you can change these particular numbers to suit your particular purpose. We should also talk real quick about leaders. So a leader, this is the multi-leader tool, is a way to call out specific information about a part. So you click on a point in the geometry that you want. It could be a particular snap point. In this case, it could be out here in the part. So I'm gonna give the person who's reading this drawing some information about the surface in here. So I'm actually just going to have my leader pointing to that surface. So click again, and then we're ready to type. So we can say something to the effect of grind and polish, because we want a ground and polish surface, right? And that's how you create a leader. If you want to have a leader to a feature like a diameter, a lot of times what I'll do is I'll use the diameter dimension. Excuse my dimension lines crossing for just the moment. And I will edit this. I'll just delete the dimension and say and of course you can justify this left as you wish. That works really well for round features and for arcs, because the diameter dimension automatically lines up your extension line with the diameter of the hole, and that's pretty standard. It's what people are going to expect to see. But if you're not dimensioning to a radial feature or a diametrical feature, then a multi-leader is certainly the way to go. Unfortunately, AutoCAD's leaders and dimensions are not necessarily linked, but we can certainly make this text, this leader, notice the arrow is out of scale as well as the text. So we can go into our leader styles, and we can do the same thing. We can modify our leader style. Things are in a little bit different place. Under the leader structure tab, there is a scale. So we had 0.75 for our dimension scale. We'll go ahead and put 0.75 in for our leader scale. All right, so things got a lot better, but the text is still not the same. The reason for that is that the text size associated with the leader and the text size associated with the dimension are not the same. So if I go back to my Dimension Styles Manager, and I'll go into Modify, and I'll go to Text, notice my text height is set to 0.15. All right, so now I know what my dimension text height is. I'm going to go to my Leader Style Manager, and I'm going to Modify, and I'm going to change the leader text height under the Content tab to the same thing, 0.15. Okay, close, and now we have our leader text much closer to our dimension text. That covers most of what we need to talk about as far as dimensions. The only other thing I'd like to add is two more dimension types. So let me go in here and put a fillet or a radius on these. So put radii on all these sharp corners. So as I said, we usually want to use the diameter dimension for holes. We want to use the radius dimension for radii. So simply click the radius dimension, click a feature, and then drag the dimension where you want. It's bad practice to have your dimensions inside the outline of your part. So you want to avoid that if you at all can. You can't always do it, but wherever you can. So I'm going to place this radius on the outside. Notice that the extension line is aligning with the radius. Click on that. Let's see, I have 1, 2, 3, 4, 5 of these radii. So I'm going to edit this to say 5. Oops. So if you make a mistake, just hit escape. Don't save your changes. Let's try that again. So again, you can hopefully imagine that if I tried to dimension every one of these radii and then started putting in all the other dimensions, the drawing would be very crowded and very hard to read. I usually don't put the center mark in for the other radii. You can if you wish. Another feature that we haven't talked about yet is angular. Angular dimensions just take a little bit of trial and error, to be quite honest. So I'm going to, you click a line, right? When you use the angular dimension, you have to give it 2 lines. So this is going to be my first line, this is going to be my second line, and then I can place my dimension where I want. Again, sort of bad practice would be to do something like this. You usually don't want to use an object line as one of your extension lines, which is happening here. Better practice is to do something like this, where you actually have 2 dimension lines. Again, you really have to take all that with a grain of salt, because sometimes it's just not possible to do everything perfectly. Remember, drawing is a communication exercise. Okay. And so that's the angle dimension. That's one way to dimension this. We can certainly dimension its angle, and then we could also dimension its length. Let's go ahead and do this. To discuss that, let me undo a few things. Get back to sharp angles. Right, so here, what we've done is I've taken out the radii here and here. So to make that point, I can dimension it like this. All right. And then I would also have to dimension a length. This would be an aligned dimension. So I could do something like this. Again, bad practice really to have the dimension lines crossing. So this is a case where I would probably go ahead and put in the line dimension and then create an angular dimension See, we could create it there. We could also create it there. So again, it's not the best practice, but it can be done that way because there's really no other way to dimension this angle with this aligned dimension in the way. To get around that, it might even be better, and it kind of again depends what you want to communicate. You might be better. The other way we can dimension this angle is to give it 2 linear dimensions. Right? We can specify the line segment as either a direction, an angle and a distance, or we can also specify it as 2 distances. And so this would be an alternative way. This would probably, unless the angle of that line was especially important to me and I really wanted to call out to somebody, hey, this is the angle, this is probably how I would do it. The person operating a machine tool is actually going to be able to use this information more than the angle information. But again, it's up to you. It depends on your purpose.